Today we are talking about some absolute value functions, and all that really means is any function that has absolute value inside of it somewhere. So before we begin, we need to talk about what does absolute value really do. And I'm hoping if you're sitting in a calculus class at this point that you know that the absolute value of a positive number is just the positive number, just equals itself. The absolute value of a negative number happens to be the positive version of that, okay? So that's what absolute value does. And also, if you remember this, it really measures the distance a number is from zero. So that's another way we talk about absolute value, because here's 0 right here, right? Well, 3 is 3 away from 0. So that's why absolute value doesn't do anything to it, just 3. And negative 3 is also 3 away from 0. So it just tells you the distance a number is from 0. There you go, no problem. But what happens if what's inside of that absolute value isn't a number at all? Oh no. What if what's inside of there is some crazy function? So let's get, I'm erasing all this stuff. What if this happened to be, I don't know, 2x plus 6? Well, now the absolute value, remember, it only does two things. It either leaves it alone or it changes the sign. So let's go to the next slide here. How about that? There we go. I typed it up. I don't know why I just wrote that on the last slide. But anyway, how does it affect functions? Here we are. Well, all f of x is going to turn into here is, if we start plugging numbers into f of x, for instance, f of 3. Well, f of 3 is 2 times 3, the absolute value of 2 times 3 plus 6, which is 6 plus 6, which is the absolute value of 12, which is 12. So notice this. F of 3 is the same exact thing as 2x plus 6. Okay? F of 3 is just 2 times 3 plus 6. Same exact thing. However, f of negative 4, I'm just picking random numbers here, okay? If you plug in negative 4, you get 2 times negative 4 plus 6. That should be an absolute value guy. 2 times negative 4 plus 6, which is negative 8 plus 6, which is the absolute value of negative 2, which is 2. So now f of x does not equal 2x plus 6, because, check this out, 2x plus 6 at negative 4 is 2 times negative 4 plus 6 is negative 2. Now f of x equals the opposite of 2x plus 6. Now I'm going to say that again. At negative 4, 2x plus 6 equals negative 2. That's where we got this number from. So 2x plus 6 is negative 2 when x is negative 4. But f of x equals positive 2 because the absolute value changed the sign. So f of x either equals 2x plus 6 or it equals the opposite of 2x plus 6. So this is the idea you want to kind of get in your head here. When you see absolute value, all it ever does is it either leaves what's inside alone, so you would get 2x plus 6, or it changes the sign. Okay? Now this negative is not meaning that this is a negative number here, okay? It just means you're changing the sign of whatever you get out of here. So actually, this only happens when 2x plus 6 is a negative number, and then the negative out front is going to change it to positive. That's exactly what happened down here. I plugged in negative 4, I got negative 2, and the absolute value changed it to 2. That's the same exact thing as this. It's the same exact thing as saying, well, that's just the opposite of 2 times negative 4 plus 6, which is the opposite of negative 2, which is 2. It's the same idea. So, key things to remember about absolute value. First thing, absolute value does not do anything if what's inside the bars, the absolute value bars, is positive or 0, because the absolute value of a positive number is just that number. The absolute value of 0 is just 0. So, let's take a look at that function we were working with. That absolute value of 2x plus 6. Well, this is just going to equal 2x plus 6 as long as, so let's say this, let's write this. F of x just equals 2x plus 6 as long as if 2x plus 6 is greater than or equal to 0. As long as 2x plus 6 is greater than or equal to 0, then f of x just equals 2x plus 6, because the absolute value won't change the sign. Well, f is going to equal 2x plus 6. This is going to be positive when x is greater than or equal to negative 3. Okay, that's the same. These are equivalent ideas here. So what that means is if you plug in any number greater than or equal to negative 3 into f of x, you're going to get 2x plus 6. So let's try a couple out here just to make sure. Let's find f of, 0. Well, when you plug 0 in, you get the absolute value of 0 plus 6, which is 6. That's the same thing as just doing without the absolute value bars. You get the same thing, okay? You just get 6. So the absolute value bars didn't do anything. They just gave us back 2x plus 6. Key thing about absolute value, it is a lazy function if what's inside is positive. All right? It only changes the sign if the argument, that's what's inside the bars, is negative. So let's go back to my f of x example, which was the absolute value of 2x plus 6. Well, if I could plug in an x value and make this thing negative, now the absolute value is going to change that sign. Well, that's going to happen when 2x plus 6 is less than 0, which is the same thing as saying that x is less than negative 3. So if x is less than negative 3, 2x plus 6 is less than 0, and the absolute value is going to change the sign, which means f of x really equals the opposite of 2x plus 6 if x is less than negative 3. Okay, a couple examples. Plug in negative 7. F of negative 7 is the absolute value of 2 times negative 7 plus 6. Well, that's negative 14 plus 6, which is negative 8, and the absolute value of negative 8 is 8. Well, that's the same exact freaking thing as doing the opposite of 2x plus 6. The opposite, the negative, of 2 times negative 7 plus 6 is the opposite of negative 8, which is 8. You get the same exact thing, okay? So f of x is the opposite of 2x plus 6 if x is less than negative 3. And let's go back a slide here. It will just equal 2x plus 6 if x is greater than or equal to negative 3. And that always happens with absolute value. The split, like where it changes sign here, will always be the same x value because that's where it equals 0. So it equals 2x plus 6 when x is greater than or equal to negative 3. And it equals the opposite of 2x plus 6 if x is less than negative 3. So that allows us to write f of x as a piecewise function. There's two parts. It either equals 2x plus 6 or it equals negative 2x plus 6. So why does it matter to me? It's important that you can take an absolute value function and rewrite it as a piecewise function because that's one thing that calc students struggle with every single year when I teach them. They get to an absolute value function and they want it to work the same way that all functions work. They want it to, we're going to start deriving and integrating it, and they want to just integrate it straight through or derive it straight through. And I know those words don't mean a lot to you at this point. But basically it means that the function doesn't work the way you want it to work. So you need to understand exactly what's going on so that you can handle it. And in order to do that, you need to be able to rewrite this as a piecewise function, because once you see it as a piecewise function, it makes a whole lot more sense. So all we're going to do to rewrite it as a piecewise function is we're going to say that f of x, and piecewise functions have this little bracket guy here, and you just write what f of x is going to equal. Well, the absolute value gives us a concise way of writing what it's going to equal, but it's misleading. So when we rewrite this as a piecewise function, what you're going to do is say that f of x either equals the opposite of what's inside those absolute value bars. The absolute value either, that's a parenthesis here, the absolute value either changes the sign or it just leaves it alone. F of x either equals the opposite of 2x plus 6 or it equals 2x plus 6. And it's going to equal the opposite of 2x plus 6, remember, when 2x plus 6 is negative. If 2x plus 6 is negative, if less than 0, then the absolute value changes the sign. Well, that happens when x is less than negative 3. It's going to equal just 2x plus 6 when 2x plus 6 is greater than 0. Well, that happens when x is greater than negative 3. And when 2x plus 6 equals 0, which happens at negative 3, then you just get the absolute value of 0, which is 0. So really, it doesn't matter where you put the equals. Like you can put the equal bar here, or you can put the equal bar on this one. It doesn't matter, because it doesn't matter which one of these you plug negative 3 into. You're going to get 0 either way. But do not put the equal sign on both of them. You can't plug negative 3 into both of them. You can only plug it into one. So, but it doesn't matter which one you plug it into. So typically, I always tell my kids, put it with the, say that it's going to equal 2x plus 6 when 2x plus 6 is greater than or equal to 0. And then when you solve it, you get x is greater than or equal to 3. All right. Again, it really doesn't matter because you're going to get 0 either way. It doesn't matter if you plug into the top function here or the bottom function. They're both 0 at negative 3. So you can put the equal bar wherever you want. But now that we've rewritten this as a piecewise function, right here, so this f of x down here with the piecewise is the same exact thing as the f of x with the absolute value here. But the piecewise function really lets you see that this is really two individual functions, the opposite of 2x plus 6 and 2x plus 6. So hopefully that wasn't too bad, and you're going to practice that a little bit in the worksheets. There's some examples in the worksheet that we go through. So what other craziness can you expect? What else is going to happen with this thing? Well, really, as long as you remember that absolute value only equals what's inside or the opposite of what's inside, you can always rewrite an absolute value function. So let's take an example of one that's a little bit harder. Let's say you have the absolute value of 3 to the x minus, 6. Okay? And let's say your goal is to rewrite this as a piecewise function. You want to know what functions can this thing equal. Well, the rule is, ready, the very first thing you do is you say that f of x will equal 3 to the x minus 6. It'll just equal what's inside if what's inside is positive. If 3 to the x minus 6 is greater than or equal to 0. Okay? It will equal the opposite of what's inside, so negative 3 to the x minus 6 if 3 to the x minus 6 is less than 0. So all we need to do now, so these are the pieces that's going to equal here, okay? 3x minus 6 or the opposite of 3x minus 6. But we can't leave it like this. We can't say if 3 to the x minus 6 is greater than or equal to 0. We want to rewrite it so that we have an actual x value on an interval, okay? We don't want a function to be less than or equal to something. We want x to be less than or equal to something. So we actually have to simplify. But to simplify them, we're just going to look at one for right now. So let's get rid of this. Let's find out where 3 to the x minus 6 is greater than or equal to 0. Because where it's greater than or equal to 0, then f of x will just equal 3x minus 6 because the absolute value won't be doing anything. So to solve this, we gotta find out what x is going to be. We add 6 to both sides. Well, that's no problem. Looks like it is a problem for me. Okay, there's no problem. It equals 6 over here, and we rewrite it as a logarithm. So if we want 3 to the x to be greater than 6, then we need x to be greater than or equal to log base 3 of 6. Okay, we need 3 to the x to be greater than or equal to 6. That's how you rewrite that exponentially. So as long as x is greater than log base 3 of 6, which is just some number, it's between 1 and 2, because 3 to the 1 is 3, and 3 squared is 9. So 3 to like the 1 point something is going to give us 6. So f of x will equal 3x minus 6 if x is greater than or equal to log base 3 of 6. But it's going to equal the opposite of 3x minus 6. So just negative 3 to the x minus 6 if, well, now we'd have to solve that other inequality. But all the other inequality was this wasn't less or greater than or equal to, it was a less than sign. So it would be if x is less than log base 3 of 6. So it is going to equal the opposite of 3x minus 6 when x is less than log base 3 of 6. So main goal, when you have an absolute value function, all you're going to do is realize that it either equals what's inside 3 to the x minus 6, or it equals the opposite of what's inside, negative 3 to the x minus 6. It equals what's inside when what's inside is positive. It equals the opposite of what's inside when what's inside is negative. And then you solve the inequality, and then you set up your little piecewise function here. No biggie.